I'm going to introduce today's lesson by showing you something on Desmos. The lesson is about transformations of functions, and what you're going to be doing is working your way through the Heggerty tasks that I've set. There are 6 of these, but don't be alarmed because they're all very short and I don't want you to make any notes or anything like that. I just want you to work through the exercises. Watch the videos first and work through the exercises. I thought long and hard about this, and I could have set up other questions for you, but to be honest with you, it's the sort of topic which is quite fiddly to put together exercises on, and I've checked the Heggerty videos and I think it explains it really well. But just to give you a little bit of a start, I'm just going to introduce the topic because it's a bit of a new one for you. It's a bit weird because you won't have seen anything quite like this before. So let me just zoom in a little bit on here. There we go, that's better I think. And it's to do with graphs. So you're used to the idea of graphs. I mean, the last topic was about them, wasn't it? Linear inequalities. There's y equals x squared, y equals x cubed, etc. And you can put whatever you like here. And sine x looks like that. Okay, so these are graphs, and basically they're a visual representation of a relationship between two variables y and x. X being the input variable, and or independent variable if you're in science, or explanatory variable, I think they call it, and then y is the answer, if you like, the response variable or dependent variable in physics or science or whatever. So y equals, and then you put a function of x in, and that generates the graph. Now, a slightly alternative way of thinking about what happens when you apply a function, when you do something to the x value to get the y value, is to think of the x, what's happening, as a function, as something that does something to an x value. So rather than write y equals x squared, say, like that, I can instead use a new little bit of notation for you, which is to give what's happening a name. I'm going to call it f. F for function. So what does f do to x? What does the function do to x? It squares it. Let's take a look at that for a minute. It's exactly the same as me saying y equals x squared, except I haven't sort of called it y, I've called it f of x, where f is what you're going to do to x. It's very simple, it works in the same way. You put a number in there, so for example, if I put 10 in there, f of 10 would be 10 squared would be 100. So f of 10 would be 100, f of 2 would be 4, etc, etc. And the answers that come out, just like the y values, get plotted. So 10, 100 would have been on here, 2, 4 is, you can see it there, etc, etc. So that's what a function is. Just another way of thinking about a relationship between two variables, except we don't really give the second variable a name. We just talk about the output value as f of whatever went in. Okay, it's a bit weird when you first see it, but you'll soon get used to it. So the series of 6 videos that you're going to be working through are basically things that you do to a function. So there's x squared, and we're going to do things to it. So when I say do things to it, I mean do mathematical things to it. And there are basically 6 different things that you can do to a function, hence 6 videos for you to work through. I can't remember, I haven't checked, so I don't know what the order of them is, but I'm going to start with the one that most people find the easiest to understand, which is what happens when you add a value to the end of a function. So if I say add 3 to the end of this function, what do you think is going to happen on the graph? Well, let's find out. It goes to there. We change it to a 4, it goes to there. Change it to a 5, it goes to there. I think it'll happen if I put a -2 in, it goes to there. Hopefully you can see that what is happening is the function is moving up and down, and that's what that does. So putting +a on the end of a function just moves it up or down by a. So f of x plus 5 is there, f of x minus 3 is there, etc, etc. I'll leave it at f of x plus 2. Okay, and so that's 3, isn't it? Let's go back down 1. Sorry, f of x plus 2. So there we are. That's f of x plus 2 for that original function x squared. Okay, now here's the interesting thing. If I change this from x squared to x cubed, obviously I get a new start function, the red one, but look at f of x plus 2. It's still 2 up from the original function. So that's the beauty of this whole concept is it doesn't matter what the original function is. The adding 2 to it will move it up 2 on a graph. So you need to understand that that's what f of x plus a does. It moves a graph up or down if a is negative by the value given there. Okay. Right, I don't want to make this video too long, so I'm not going to go through all 6 transformations in this video. So I'm just going to do a couple more. So the second one I want to show you is, let me go back to x squared again so you can see the original function, is what happens if you put a number in front of the f of x. So for example, 2 f of x, like that. Let me just get rid of the blue one temporarily so you can see. So there is 2 f of x. So this time it hasn't moved the graph up, it's kind of stretched it up. So this value here didn't move at all. But the further you were away from the x-axis to start with, the more effect it had. So for example, this point here, which was 2, 4, has now become 2, 8 here. And this point here, which is 3, 9, has become 3, oh God, I didn't mean to do that, has become 3, 18 up here. So what's happened is the graph has been stretched in the y direction. Okay, and that's what's happened by putting the 2 there. Once again, if I change it to a, like so, and let's make it b so it doesn't interfere with the other one that I've already set up. If I make it b like that, and I set b to 2, that's where we were. And what happens is, if I change b to 3, it stretches up more. If I change it to 4, it stretches up more. So everything, the further you are away, the more further you are away when you've made the transformation. You multiply the distance you are away from the x-axis by the factor b. What do you think happens if it goes negative? Let's try -1. Interesting. So minus 1 f of x just turns the graph upside down. So if you stretch in a negative direction, not only do you stretch the graph, let me show you -2, but you oh God, I'm not very good at this, am I? But you also turn it upside down as well. So we've got f of x plus a, we've got b f of x, and there are others. Well, there are really 2 others. And I'm not going to explain them now because you can come across them in the video, and next time we meet I will go over the other 2 main ones that there are. There are 6 altogether, I said, but there are 4 main ones, and 2 of them also include the case where you have a minus f of x. Well, I've kind of effectively shown you 3 so far, because as well as the one that just moves up and down, you've got the one that stretches, and you've got the special case of stretching by a factor of -1, okay, which is such a special case, it has its own video on Hegarty, minus f of x, which turns a graph upside down. Let me put this one back on so you can see it. So we've got minus f of x there, and we've got f of x plus 2 there. Zoom out a little bit. I just want to show you again that it doesn't matter what the original function is, it still does all the same things. Okay, so have a look. I mean, just check you understand. The red one is the original. The blue one is it f of x plus 2, moves it up 2. And the green one is minus f of x, which flips it upside down. So there's a little introduction to functions. I'm going to overwhelm you if I keep going. There is a lot more to this, but it should allow you to at least have a little go at the videos. To spend up to an hour on them now, and I will check at the end of the lesson to see where you are up to with that. Thank you for listening. Have a good day, Year 10.